lunch and learn for the year. We have scheduled per month one WRE lunch and learn. So today we are going to do basics about the drainage design, and Dave has created some materials. Ankur myself reviewed it, provided input, went to Katie also for the formal filings. So basically we will have a recorded version of this one also. If somebody can go back and reference, they can do it, and also we can get a one pdf for this lunch and learn. With that being said, I just want to mention couple of things. For the drainage design, as Pushkar provided for federal highway design, we need to follow both state and federal. They are available online if you Google highway drainage manual. And also for the state and local and cities, all others, basically we follow the state highway drainage manual September 2023 revised. So if you type highway drainage manual September 2023, it takes to the maryland.gov and has a single PDF, and then everything is there. I don't want to take more time here. Request Dave. Dave, thank you for compiling these. I request Dave to start the presentation.
Okay, I'm gonna share my screen.
Yeah, you can share your screen and explain whatever. And this is an open forum, not a formal. Everybody can chip in their knowledges. But basically, I request you first finish the presentation, or people can ask questions whenever necessary.
Probably just open it read only.
Shalim, are you in the file?
No, I'm not. Ankur, are you?
Maybe I was looking into it.
Yeah, let's close that one, please.
Okay, let's see.
We may need to edit it based on the feedback. So let's open read and write version, please, Dev.
Might just need to close it and read, or yeah.
Okay, can everybody see that I'm screen?
Yes.
Yep.
Okay, this is drainage design and very trusted. This is gonna be part one of drainage design of what and how we design stuff for storm drains and inlet. Okay, so this is an introduction to the importance of being effective design. Um, you know, we have to design it very properly to prevent overflooding for infrastructure and maintain water quality. You know, it's very important to understand the basic beginning of hydrology and system layout and the environmental impact just to make sure that it's effective for long term.
Yeah. Just to point to this, like a lot of our water resource stuff is, some of it is a little bit more about the maybe environmental impacts or, just kind of getting through permit procedures. But this is one aspect, drainage design, roadway design, it ties with roadway design, and it's an aspect that is pretty important, as our, we're all as engineers, it's our, duty to maintain public safety, and this is kind of one major thing that it's important to make sure we do things properly for this, do our math correctly for drainage design, hydraulic design, which we're going to discuss today. But this is an aspect that, if you're cutting corners, don't cut it on this one, because this is something that, affects real things, and we want to make sure things are safe and for the public, ultimately, and this plays a big part in it.
Yeah, so all so like what I was saying about the consequences of inadequate drainage, through traffic safety hazards. When you have an adequate drainage system, if you need to like water being flooded on roadways, and if water being flooded, you can increase accidents on the road due to ice formation and cold water. As you can see this year, recently we had a lot of winter storms and ice on the road. You know, if it's not designed correctly, water stays on the road. The water contains ice and cold water. Hydroplaning, things like that. So here's an example of before.
Old election ad.
Add
Does this video has a sound?
Dorchester County.
I'm saying it. Does it have a sound?
Think we can skip through, but I'm not sure if you had any specific thing with this one, but or what caused it, but
Like you see this. There's
Yeah,
some cracks in the storm drainage here.
Hmm.
And then it was a collapse. So
right.
you see there's multiple erosion and stuff. When it's a high storm, the water will cause it to erode and then provide crash. So that's just one example of how traffic safety and an adequate drainage system can lead to um safety hazards. Mm. And as well as property damage risk. Poor Sanjay can infiltrate, buildings, structural damage, erosion, which, significant financial burden for property owners. And one sometimes we get complaints from county saying that, their property is being flooded. So we have to go out and assess the damage and provide way to design and so it's less flooding. Okay. So how do we begin with analyzing the system? Well, usually we give project we propose for drainage design. So first thing you want to do is to determine your jurisdiction of the project. Is it a county project? Is it a state project? Is it a town or a city project? And the reason why is because each entity has its own drainage manual with design criteria to follow. And usually, if the county doesn't have like a drainage manual, they usually follow MDOT, I should say, drainage manual that control the design. So, but it varies sometimes. I know one example was Anne Arundel County. They have their own drainage manual and rules to follow, and so that's what to do it. And then the next way the next step is to confirm your roadway classification and be sure to check with highway as well to confirm the roadway classification. Now, what roadway classification is, it determines the road design, which we will get into next in a couple of slides over. And, and one way to check is we have GIS data, yeah, and this is a resource that we use all the time to determine the road classification. Just view map, and the map comes up, and you type in the address of the project, and it will usually give you the roadway classification. And each roadway classification comes with a certain design form, like 10-year, 50-year, 25-year design form. So if you have time, check out this site and root around it a little bit.
Yeah, Dev, can you explain the functional classification is used for only the cross culverts, bridges, or other structures also?
think- Yeah, I think we have some more slides on that, but just to touch on the thing, make sure like what David said in the beginning, we most of our work is, or a large portion of our work is with MDOT SHA, so we tend to be very familiar with their design procedures and their criteria for
Yeah.
type and structure design. But if we're working on any county or town, if you're not sure as like a design engineer, check with the PM and confirm which rules apply. And in some cases where for example, our town of Kensington projects, they don't have their own drainage manuals. So, they told us early on that we can follow MDOT guidelines. So, most people will, default to the state agency, which will be MDOT in this case. But if that's something that we really need to make sure is confirmed before we really start any work.
Yeah. Good. Go ahead, Dev. Sorry for interruption.
So it's a general design guideline. You have to account for the future in terms of long-term functionality. But what I mean is that, we do a lot of work within the roadway for the future, whether we're widening the roadway. So we have to make sure that any pipe or structure that's directly impacted by the roadway gets investigated and designed. Any structure within the work area with a visual defect should be replaced, which we cover with like a site visit. We will go out to a site visit and see which pipes are damaged due to erosion, or sometimes it's so old. It was designed in like 1960, and it's a CMP pipe. And now the current manual will tell you have upgrade the pipe to concrete pipe. And then one thing to consider when designing drainage is you want to make sure you have all your information that you need. That includes all your utilities, survey file, environmental features when designing the layout. The reason why is because we want to avoid conflict as much as possible, because it's relatively expensive to relocate utilities, and it'll add complexity to the project design, and that will result in project delay. So if you design your drainage ahead of time, trying to avoid conflicts, it'll be much easier in the future to make adjustments.
Yeah, and if you're done, Dave, just to touch on that first bullet a little bit more, this is a key thing, and it is a kind of a point of contention in a lot of projects. Is generally jurisdictions or some reviewer from the jurisdiction will end up wanting us to fix a lot of the drainage structures that are, I'll say, nearby where we're working. If we're widening a road or doing some roadway sidewalk improvements, whatever we are doing, they will want us to definitely check anything that we are hydrologically impacting. So that means like if we're adding impervious area, adding sidewalk next to an inlet, so that they'll, what happens is there'll be more water coming to that inlet if we add impervious area. So we have to resize them and make sure that they're up to the current standards. But a lot of times what the contention is like, the next downstream structure, are we also going to fix that one if that is undersized, or there's some issue with there's some structural defects and cracks or something in it. So that always is a point of discussion. So that's another thing that you please make sure you confirm with the PMs. A lot of times we have to really iron that out in the scope, or if something was missed in the scope, we have to request an extra work order for that kind of stuff. So just be a little bit careful and don't just start analyzing the whole corridor of a long PSAP project or something, because then once we start putting calculations, we have to own them. We have to make sure they're carried through to the final design, and ends up becoming a big effort that may or may not have been included in our original scope.
I would like to add, Anchor, you have provided really good explanation why we need, all those, the information in bullet 1 and 2. I think the most important bullet here is really bullet 3 when we are talking about the utilities. And so sometimes we don't look at the utilities, and suddenly, we have put together, our concept design plans, and our reviewer finds that there is a utility conflict. I think a third, all these 3 bullets are equally important, particularly the third, because that if we have considered those factors, I think that might reduce our the number of iterations for any concept level design, and then the follow-up design. So I mean, you have really put together really nice factors which are very important when we are looking at the design level on the third bullet.
Yeah, make sure all those files are on, basically, the MUT, MTO, MEF, like make sure they're all on when you're drawing, but doing the design, so we can avoid where possible. In general, electric lines are usually a little bit more, easy to relocate. Fiber optic, gas, we want to avoid. Sewer, water, all those we want to avoid if at all possible. A lot of the more urban areas, it is impossible, but we have to do what we can to minimize it.
Good.
So there are a lot of key definitions, just basic overview of storm drainage, pipes, inlet, outfalls, to manage stormwater runoff, And then the second one is the hydrology part of it, because understanding hydrology is essential, because that's how we get the amount of flow, and that's how we decide how to guide our pipes based on the flow area. And this is where the flow design storm significantly comes into play with the roadway classification. The design storm is how we determine how our storm drainage can handle future storms. So number 1 is storm design component. So this is basically just storm drain criteria when designing storm drains and pipes. Full velocity are not less than 3 feet per second. And as well as not being exceeded 10 feet per second velocity with such a high velocity, it can cause abrasion. And I said typically a closed tumbling system is usually designed for the 10-year flow, and hydraulic grading for the 25-year storm must remain below the finish grade. So the hydraulic graded 25-year storm is the feature on 25-year storm that we predict during very, very high weather storm. And the reason why we want to finish below the finish grade is so that it doesn't overtop the roadway.
Yeah, so I guess, you know, the first one, for the less than 3 feet per second, you don't want, you know, where possible, you don't want to put very flat pipes. That's why a lot of jurisdictions have like a minimum slope of 1% or 2% of the pipe slope. And that's just so, you know, whatever leaves and debris gets inside of it will wash away and wash through the system and not clog it up forever. And then, you know, the balance is you don't want it too fast because of potential for erosion at the outfall, which you can, you know, mitigate with riprap, but you know, depending
Yeah,
on the
that's yeah,
material of pipe.
that's cool. That's very good point, Ankur. SHA want us to have a minimum self-cleaning velocity inside the structure so that debris cannot be accumulated. In a hard case, they allow 0.5, but 1 or 1.5 is good. That's what Ankur told. Yeah, go ahead.
Yeah, so we always try to design it for a minimum of 1%. Due to circumstances, due to like unmitigated circumstances, sometimes they will allow 0.5% stuff, but we like to design it in terms of like concept design. We always try to do 1% minimum just to give us room to play around with the design.
Yeah, and that's basically where the utility, you know, test pit information comes in. You know, you may want to move the pipe up or down, and that affects the whole system, and you know, your slopes are affected in that way.
Right.
And yeah, I mean, I don't think we need to get too far into the, you know, calculations of like HGL and things like that, but basically,
Yeah.
you know, the different jurisdictions basically dictate what year storm, and like kind of what capacity it's going to be designed to handle. So the one he has listed here is the MDOT criteria. Yeah, Habib, did you have something?
Yeah, I see that Pushkar raised the question about the video inspection. I joined late. Did you already respond to that question?
Oh, no, yeah, that VPI thing is something that HHD has been, you know, requesting for the past year or so. I'm not sure what changed in there. Maybe it's the new manual. They're trying to revamp their whole systems, but you know, that's the only, you know, if we video, most of these pipes are underground, so we can inspect it, you know, near the inlet and manholes, but further underground, if there's a giant crack and there's some siphoning happening, you know, like water's leaving the pipe somewhere, that does have the potential for, you know, causing sinkholes or, you know, washing, you know, things like that, and you want to avoid. So there's no really way to know that without, unless other than a VPI. I think MDOT could do maybe a better job of like only requesting them for pipes that are, you know, after a certain year of service life. I don't know what they would
Yeah.
make it up, but you know, 25-year-old plus pipes need to be VPI'd or something to that effect. But right now they're just giving us blanket rules. So, you know, it depends on the case. If we have as-built, maybe that's some argument point we can make, is if they're newer system, maybe, you know, they don't need to waste the money to do that. But that does become like a big headache, because, you know, if we do see a crack in something that needs to be replaced, then that has ramifications for roadway design, including MOT. And obviously our drainage and stormwater and ENS as well. So it kind of is a open, it's a can of worms, getting that stuff added in.
Yeah, I have one more question. I mean, you don't have to answer this. I was going to reach out to you separately because I need to talk to CV. So, but they will ask how much effort it is, so we need to give some kind of detail to them for them to do their scope. So if you want to do that separately, we can do that, unless you want to mention something which will benefit the people here.
You mean for VPI, like the pipe inspection? Or
Yeah,
something?
yep.
I mean, the people doing it should know, but typically they give us a video of like, they drive a little remote control car with a camera inside the pipe, and they give us a video of that, and then they prepare a log saying, where the cracks or any deformities. Someone basically reviews the footage and checks for defects and notes it in a report.
So basically, the project limits is enough information for them to develop their scope.
Well, I can give some update on, information on this one. Ankur, if you remember correctly, they did the video inspection on US 13 business over Waikamico. They provided us the video inspection file, videos. So that effort was not much. I mean, if you know which pipes needs to be video inspected, you can just calculate the linear footage. I think they have, the companies usually, in our US 13 case, I think it was like $4,000 or $5,000. It's not going to be that high price, because what they do is they put a camera on a rover with a remote control. They just send it in, and it captures everything. Or sometimes they even fly a small drone if the pipe is big enough. They fly a small drone inside the pipe to get a video capture the entire pipe condition. But the efforts are not that big. It's very minimal.
Yeah, Sayak is correct. Effort is not that big. In Swan Harbor DMP site, we just completed 1,300 linear foot of pipe BD inspection within $5,000 done by a AV consultant. What they do, they send a BD robot with the 4 wheels and then camera in the head. That camera is 360-degree rotatable, can find if there is any structure damage up in the ground, they can locate it and give you a linear footage wise video, so that you can know where is the damage starting from 0 to which station. So yeah, that site is correct. That is available, not a big effort. So, but it depends upon Puskar's question is, it depends upon how, if it covers in our scope or not, but it is doable.
So
Yeah,
basically, we need to give them linear footage or number of pipes.
Well, if you have the existing pipe inventory, you can give them the linear footage and the size of the pipes, because they need to know the size of the pipe. If the pipe size is like 18-inch pipe size, it's very difficult to do. But if the pipe size is a little bit bigger, then sometimes those 18-inch pipes are clogged. They cannot even pass through. So in those cases, what they have to do is they have to go to either side of the stop blockage, and send the rover or the drone from the manhole from one side, and then go back from the other side and find out. They geolocate it basically. I think AI data, they do the pipe inspections as well. You can take a look at their website, and if you want to talk, if you want to talk to them, you can just talk to them and ask them how much effort it is. They can give you a better answer maybe.
I mean, the question is how old the existing drainage system is. So that basically dictates, whether they need video inspection or not. Somebody they're like 50 years old existing drainage system is, and somebody, SHA or VDOT, they want to extend the, the width of the road, they want to have more lanes, and then they're looking into it. Basically, there shouldn't be any drainage issue. So at that point of time, basically, if the project is complex, they ask for the video inspection of the existing pipes. So, I mean, there has been good discussion on the video pipes, and basically that robot can figure it out. Basically, even sometimes the joints may not be there, basically, and they're not together, or, there is leakage there. So that what happens. I mean, if for small, if $100,000 design project, probably video inspection may or may not be needed. But if it is like $500,000 project, basically, probably they want to make sure that, the downstream drainage system is adequate and it can handle the flow.
All right, thank you.
Just last point on that is I think it comes from, whatever we say is whatever, but HHD is in the case we're talking about is the one that, is asking for it. So I think what they told us for 410 is we just need to video the existing pipe like downstream of where we're tying in. So, not the whole
Right.
2-mile system or whatever, but just kind of near where we're going to be tapping in. So for that project, Vivo needs to calculate that, and they can probably give you a linear footage or mark it on a plan which pipes they need to inspect.
Okay, all right, that will help. Thank you.
Let's just cover the hydrology part of it in terms of like runoff calculations and flows. When you design storm drain system, we use the rational method. This is typical for closed flow storm drain system. This will accurately model time concentration to each inlet. We typically use a minimum of 5 minutes, unless it's like a really big drainage area. And in hydrology, we use a lot of different softwares and stuff to calculate the flows. So there are three ways that you use for different portions of hydrology. So one is TR55, but TR55 is mostly used for big drainage areas such as like POI and stormwater management drainage areas, like Michael Bowers' drainage area, Boswell. Like that usually I fall to like open channels. Another stuff we use TR20. It's similar to TR55, but TR20 is more in depth to be used for like routing. If you have like a stormwater management pond, it allows you to use the same storage table in order to figure out the flow. Like I said before, the rational method is what we mainly use for the storm drain system. Now, one tip when designing storm drain and hydrology, usually in the beginning project we have POIs, the drainage areas, and sometimes the drainage area to the inlet will align with the POIs in terms of like outside. So if you're in a drainage area, it's outside your POI drainage area, that means something's wrong. They should match up. There shouldn't be anything outside of each other. It should line up with your POI drainage areas.
Right. There, can I speak for a 5 second? So TR55, TR20 are the softwares, but we have now a HydroCAD, which does both things inside, is built in within the HydroCAD also, just for information. Go ahead, Dev.
Yeah, HydroCAD, yeah, that's the new software we just Solomon's the main guy with HydroCAD.
Right.
I think he might be giving another training later on about HydroCAD.
Yeah, that's good.
Yeah, the key thing there is just TR55, TR20 is basically the same thing. It should give you the same flows. That's like if you ever see like NRCS method, that's what that is, TR55 or TR20. And then rational method, which tends to give actually less, more conservative, so higher flows than TR55, TR20. That's usually needed for closed storm drain system design. So whenever you're designing inlets and pipes in the roadway, you have to use rational method for that. But TR55 and TR20 is more for POIs, like for stormwater management drainage areas and also like for MDOT, they allow culverts to be used, culverts to be designed using that as well. So just, you know, that's a common issue or mistake you see is like, you know, someone just starts doing it and will use TR55 or something to do inlet drainage areas, and that's not the correct way. You know,
Right, Ankur is right. Also, the main important thing here is before we start analysis, we need to check with our client, do they accept or not. For example, we did a HydroCAD for one project and client told they want TR20. Somebody entertain a TR55, TR20, and somebody entertain HydroCAD too. So Ankur is right. We need to figure out which software we use right at the beginning. But definitely for the POIs, drainage areas, culverts, TR55 and TR20. For the inlet design, we must use a rational method.
I want to add one more thing, little bit. Both Anchor and Mahendra are doing good job, and including David too. So in this case, when we talk about that, we have to check with the client. I think when we are writing our task order, I think we should clearly spell it out whether we are going to use TR55 or TR20. So that will help us basically, have less wastage of time instead of figuring out at a later stage.
Yep.
Yes, some clients are really, they go for the pennies, and some clients are like SHA, they want to go on more accuracies. So, I mean, even their, the PMs have already, designated what kind of model they are looking for or not. So here I like to add a little bit more. It's going a good discussion. So TR55 is mostly used, in our design calculation. If there is small drainage area of 10 acres, it's combination of roadway and also perviousness or so, and there is small stream is going through. And we want to know what is the time of concentration so that we can design the, inlet, because contribution is from the houses too. So TR55 will help to find out what is the time of concentration there. And that could be used in the rational method because that needs input there too. So, there is the TR55 and rational formula. Sometimes they are really interconnected. TR20, I think we have good discussion, and Karalit said that it is in more complexity. If we have to design the pond or we have to route the water through the pond within our drainage system, TR20 is uh, more appropriate.
Yeah.
David, you can go on.
What? Okay. Yeah, so layouts on the system, the main thing really is consistent pipe sizing for the pipe. You don't want to, based on the flows and what you get from the jaw of your vacuum method, you want to prevent bottlenecks. So what that means is you don't want to have like a 15 pipe and then the next pipe be 12-inch. The storm drain from upstream to downstream should increase in size, not decrease. And I'll show you an example on the next slide. Okay, and as well as inlet placement, you wanna place inlets based on the spread in the drainage pattern, which we will cover in the future slides. Because inlet placement really helps a lot in terms of managing the runoff as well. And also, you have to look at the existing topo. Okay, you wanna design something system. Usually when you design a closed zoning system, it's going to alpha, right? And the alpha is usually located at a low point. And if we follow the alpha upstream, the topo goes up as well in elevation. So the main thing is you wanna you don't want to design some of the system that goes against the gravity. You know, you don't want to have, a storm system going up, going down when your elevation is going higher. You just want to follow the gravity flow of things. Because if you don't, you're gonna need you're gonna have to do some pumping, which is the result of less gravity assisted training. And the next slide is a guideline for consistent pipe system. Here's an example. With the standard guideline from the SSA manual. So the minimum pipe size is usually 50 inches for the first pipe, and then 18 inches everywhere else. And then, you know, the more flow that gets to it, the larger the pipe will be downstream. In the old manual, they used to have you used to be able to just put 15-inch pipes all the way until it hit the maximum, but now they want 18-inch pipe right after the 15-inch pipe. Then you have these transverse pipes here. You know, if you're crossing the roadway, the minimum usually is 80 inches for 6 feet or less, or 12 inch, or 24 inches for pipe like over 60 feet.
Yeah, this is another one that's I see missed a lot. So just to reiterate, the for regardless of what your calculations say, what pipe size is needed for whatever design storm you're designing it for, the minimum size for the first, we're talking about closed storm drain system like sketch there. So the first segment can be 15 inches, but after that it needs to be 18 inches, and pipes crossing the road, as mentioned, those are, a little extra criteria if they're longer than 60 feet, between the structures, structure to structure. They have to be 24 inches minimum. And that same criteria applies for culverts. Minimum is 18 inches unless it's more than 60 feet long, and then it has to be 24 inches minimum for culverts as well.
Yeah.
And when you're kind of making, drawing these pipes, make sure most MDOT, roadway inlets can fit an 18-inch pipe, but just be careful with yard inlets and things like that. Some of those, depending on you have to look at the detail, but some have a maximum pipe size of 15 inches. So you have to take that into consideration when designing it.
Yeah, here's the hydraulic performance factors, just for inlet design, environmental impact, and maintenance accessibility. So basically, what we locate unless we want to make sure that it's in the right position. And one of the main things is accessibility for easy access as well. And like I said, we want to minimize the environmental things of it while managing runoff. That's sufficient.
Yeah, I think we touched on most of that stuff already, but the maintenance is something that whatever jurisdiction they have to come to this inlet and clean it out from time to time. It doesn't happen a lot, but they should be able to access it. So basically that means that everything needs a lid on top. If it's an inlet or something, a box inlet, it needs to have a access, manhole lid kind of thing on the top so they can get in. sometimes, usually the details take care of it, but above a certain depth, you have to make sure that they have rungs, like ladder rungs inside the inlet itself, so someone can climb down if needed.
These are like strategic inlet placement, these are like basic guidelines of where to place inlet and bullet point. I'm not gonna go through all of them. I'm just gonna go through like the main stuff. Basically it's just, you know, all low points in the category.
And
Or whether,
1 second to cut you off there. That low point, that's critical. You know, we when you do that, you have to look at the profile that our highway team will usually develop. And make sure, you know, whatever station that low point is, make sure we have an inlet there. You know, if it's a couple feet away, that means there's going to be a couple feet of standing water on the roadway. So that's really critical to make sure it's that inlet. The ones that are at the low point, the sump, they have to be at the right station. Okay, go ahead, sir.
and then like, basically it tells you like what not to put them, what to put them. And one of the main things is, you don't put like in the path where a pedestrian walk. Like for example, a car walk. I remember one project, we had inlet. They proposed a car walk. Well, I remember how we put the car walk and I placed the inlet down. And then at the next iteration, I had to move that inlet to avoid it. And it's basically it's also a danger issue. You don't want people walking over inlet, you know. And then mostly we use mostly curb opening inlet, which is the preferred type in the roadway. And I'll go through the type of inlet as well. And the next slide maybe. And then you want to avoid great inlets in spiral lane and great inlets in turning or parking lane. I remember one project on US 13, like Arco could have found it. We had a great inlet and a temporary road, but we can't do that. So we decided, to convert it into like a manhole slash with an inlet with like a manhole top on it.
Yeah, that was for different reasons, but yeah, just yeah, we can't, you know, in general, like, you know, when you're driving on the road and you hit a grate inlet, you know, your car, you know, takes a little beating, and so and the inlet itself, if you think about it, you know, that thing's gonna you know, its service life is gonna be shortened a lot when cars keep driving on top of the grate. So usually, you know, if there's a shoulder there, you can put a grate inlet, if it's not the travel lane, but if there's no shoulder, we really don't want to use grate inlets.
Um,
And I think, you know, some districts will specifically tell you, tell you can't, so, and the other one I'll just mention is, something, that second or third, yeah, second bullet point. So at intersections, right, wherever you put your inlet at the intersection, sometimes, you know, it has to be a little bit further away from the intersection, because of whatever, you may have a crosswalk or whatever. So the criteria is you have to calculate the flow that's gonna, you know, flow across that roadway, so downstream of that inlet. And that flow has to be less than 1 CFS for the 10-year storm, which is not very much, um, you know, for roadway safety. So that's another thing you have to be careful of, and sometimes causes issues.
And another thing that you need to be careful about is the bike lanes, the inlet grades, um, in the bike lanes that needs to be bike compatible, wherever you place grade inlet. Is that correct?
Yeah. It's another thing we have to make sure that it's, you know, a bike compatible grade. So they have, you know, several of those that are available. So just, you know, we have to usually mention, or a lot of times the detail itself will say that, but Yeah, that's another thing we have to make sure. Yeah, I think the rest of the stuff is self-explanatory. Yep.
Yeah, so this is the table I was talking about in terms of design. Uh, Based on the roadway classification. So these are the different roadway classifications we have in the state, Western Ontario, minor Ontario, and local, and what it's all going to stop on. And you can see the design speed and design storm, based on how to do inlet design and how to display. So design speed for inlet say is 10 year, local is 5 year, but it's mostly all 10 year. And in the old manual, it used to be 2 year storm for design, but now it's 10 year, and which means more flow, which means we have put more inlet to avoid the maximum spread and thing. And so this is what you want to place inlet to intercept a minimum flow of 70% for the design to block the scene the spread. You know, now that the manual says that it's a 10 year flow for the design form, we have to try to mitigate that flow by putting more inlet or increasing the size of inlet in order to meet that spread. And then here on the last column, you see the spread restriction. It's usually, and here is the guideline for a general overview. The maximum design spread is 8 feet on all roadways. Don't want to go more than 8 feet.
Yeah. So this is the specific criteria that's caused a lot of issues for our drainage design and scoping and things. Is this manual, as David mentioned? So this manual was published by MDOT in to 2023. So, and I think basically all new projects, I think in general the criteria is if your PI was after January 2024, then you have to follow these rules. So this criteria basically they made it a lot more strict than the previous. Like David mentioned, before it was the 2 year storm and it was maximum of 8 feet of spread or half the travel lane. So now, as you can see, it's 10, 25, 50 year storm, and a lot of times it's only 3 feet. So basically, that means like any existing inlet you check is going to be undersized, and if you're touching it, they'll want you to upgrade it to this criteria, which will require like adding a lot more upstream inlets and extending the pipe network. And another thing, just to say for spread, the biggest thing that for spread is, it's literally just measuring the water depth and extrapolating it over the roadway based on the cross slope of the roadway. So if you have, say, 1% cross slope versus 2% cross slope, you'll have, double the spread or half this, the spread width will change proportionally based on your cross slope. So, just be with this in mind, wherever it's possible to, put like a little higher cross slope, it'll help out the drainage design for this reason. Just keep that in mind.
No, these are the type of inlets that we have. We have club open inlet. We have two types of club open inlet. We have club on grade and club on slab. No, we use a lot of club on grade that they can convey large water. Then we have great inlet, which is like an open in the gutter but we don't use that a lot because that's effective with the clogging and maintenance, and because they get clogged, so then the road will get flooded. So, we try to reduce the amount of greatness that we use. And then we have combination lines, which are both curb opening and great combination as well. And I have a detail on the next slide here. Okay, we have details that we use for the inlet, but each county might have their own standard detail, but less than it. So be sure to check the county website for detail before using the access joining details. Because their detail might be a little bit different, and that's the standard that they use. Here's a website they can go and look at the details. And here's an example of our detail from SSA for a basic COG and carbon lab inlet as well. Alrighty. So here's a standard detail. Now, when we use inlet for engineering design, we usually have to put a structure schedule and a pipe schedule as well. And the reason that for the structure schedule tells us what the top of structure is in elevation, and the pipe schedule shows the pipe size and the inlet in, the inlet out, and everything. And so this structure schedule is usually spit out in inroads if we design. And I have a tutorial on inroads on the outside for everybody if you want to figure out inroads for pipe design. Um, but top of structure and then the inlet. But then when you do the structure schedule, you have to figure out what the depth of the structure is here, which is this depth here, okay? And the how to find that depth is you take the top structure elevation with IE, we'll look at IE as an example. If the top structure is 101.60, and then you go to that index out for the pipe is in that invert here, 89.39. You subtract it, and then you get the depth on the structure schedule. Now, the reason why I say that you need the right structure schedule depth, because it plays a factor when we are doing cost estimate for drainage. I want to be very specific about cost estimate and drainage and inlet, because we have minimum depth versus vertical depth. As you can see in estimator, they may have your inlet is a minimum or it's a vertical depth in linear feet. So the reason why we have these two is in terms of standards, the standard inlet, they have the minimum depth here, okay? And in the cost estimate, we say, up to the minimum depth, we just pay for one inlet, right? And the unit will be each. At least then, if your inlet is deeper than that minimum depth, then we have to pay for each linear feet over the minimum depth. Okay. Now to make it a little more clear is, you have the vertical depth which we calculated here, 12.21, And then the minimum depth of a standard inlet is 5 feet 8 inches. So that means the vertical depth is 6.64 feet. That's how much extra that we have to pay in the cost estimate for the depth. Now, because on the estimate, we pay for one inlet, which is unit E, plus an additional depth of 6.64 feet. 1 linear feet. So that's what when we design long-term pipe, we always try to put our pipe inverts at minimum depth and work our way from there. And if we have to go deeper for the pipe, then we'll adjust it on the way. But type of concept, we always start, 1% slope and try and get a minimum depth for inlet. It's just to help like the contractor, have a standard that because sometimes inlets are precast and they already have it precast. They can just install it without modifying the depth a little bit. Yeah.
Yeah, just, I think, David said it all there, but, this is for the cost estimate, the structure schedule is one thing, making sure the numbers are correct, but the cost estimate is where the comparison with the minimum depth comes in, so, in this case where the minimum depth, which is noted on all the details, is 5 foot 8 inches, and we need it to be 12 foot, 12.21. So basically, this inlet is going to be an extra 6.6 feet larger. So we need a vertical depth payment item, and the cost estimate of, in this case, you always round up, so 7 feet. It would have to be added to the estimate. So that's like a QC or whatever you want to call it, whoever doing the estimate needs to check that because it's a common, it's easy to miss it because we change some invert and so we forget to update the depth. So when we're doing the estimates, we have to double check these numbers.
Yeah, Dave, people may have other meetings and anything. Let's go 6 more minutes. We will end up at 1:10 and then we will start in the next session. We will start from where we left. How that sounds, Ankur and Dev.
Yeah, there's only one more slide, so we can
Okay,
wrap it
okay,
up.
go ahead, please.
So there's only one more slide. They're talking about the CAD application, example of how to draw
Mhm.
inlets and pipe in the CAD file. It shows usually. So here's an example of what not to do. Okay. Here you have an inlet and a curve here, but you see how this inlet is placed off the curve a little bit. We don't want to do that. Okay. We don't want to do that. This is the correct way to do it. You
Right,
always
go from
want
the side, yeah. Yeah,
put on
you need to go from the side, yeah.
the sidewalk, yeah.
Yeah.
So
See, if there's
so-
like 4 white dots around the inlet box, you want to snap to one of those, whichever corner, which is just the center of the box.
Mhm. Right.
Right. And now, okay. Here's a bad example of manhole. Okay. If you have like 4 pipes in here, but there's conflict here in the pipe. There's not enough space for the pipe to go. So, and one thing we know that you have to draw the pipe so that it goes into the middle of the manhole. Right
Right.
here.
Yeah,
Okay.
and then they need to trim it to make sure there is a space in between the two pipes, at least 6 inches.
Yeah, so that's the next slide. Okay. So
Yeah, that's a CAD, yeah.
then you trim it, and then you
Yeah.
trim it to see if it will fit. So this is typically so close. So that means you might need a bigger manhole.
Yeah.
No size space.
Yeah, and also other thing, Dev, if these incoming pipes are in different vertical locations, they can be shown as a conflicting, but in the vertical, there will be a vertical gap in between. That's fine. But yeah, they brought a good point. We need to check a clearance, both horizontal and vertical clearances. Okay.
Yeah, another easy thing to miss, just, base keeping when you're drawing them, snap to the center of the manhole, and then that's because that's actually how they're gonna construct it. If you show it into one corner or like one side of it, that's not they're not gonna actually construct it that way. So it may look
No,
like
yeah.
the manhole will fit, but when they go to construction, they'll call us and cause a headache. So, yeah, it's easy to do, something that, when you're drawing it, because in review, it's gonna be tiny and, we're not gonna notice. So really, when you're drawing it, that's something that needs to be done correctly.
Yep. And other thing I like to add, I know we are more, if we cannot fit the pipes with the range of the manhole diameters we have, then the next we need to construct the project anyway. Next is have a special structure, a bolt. That is structure people need to be involved. That is another story.
That concludes the presentation.
Presentation is cool. Thank you, Dev, Ankur. Very good presentation. We really appreciate. We'll follow up with another presentation next time. So we are more than I think 8 minutes more. So people can send their questions either to Ankur, myself, Salim, and Dave. Thank you very much for your participations. Thank you. See you in next presentation.
Thank you.
Yep, thank you, everyone.
Thanks, everyone.